Okay, so first we will go with the cloud enabling technologies, and the first one is the broadband networks and the internet architecture. Broadband networks and the internet architecture. I think by this time you are pretty sure that internet is the most important and minimal component that will be requiring if you want to be part of a cloud. Internet. Without the internet connectivity, definitely you cannot say that you are in the cloud, and you cannot tell that you are functioning with the cloud. Why? Because all the IT resources that are available in the cloud are supposed to be accessed in a from a remote location only. From a remote location only, they are supposed to be accessed. So in order to have that in a remote location access, definitely there should be internet connectivity. Internet connectivity. Remember, don't get confused with today's session when I was talking about multiple deployment models, and I was talking about intercloud, the cloud which connects other two clouds. This is similar, other than that particular thing. Okay, this is not similar to that. Here we are talking about just one-to-one connectivity, one-to-one connectivity, and for this definitely we definitely require internet, no doubt about it. And if you can see how this internet service providers are hierarchically, and how they are categorized into, if you can look in, we understand that all the ISPs are prepared in such tiers, in three tiers. You call them tier 1, tier 2, and tier 3. You can take any internet service provider. Now, I think you know internet service providers. Do you know who are internet service providers? They are nothing but who provides you the internet, man. Now, if you have a connectivity, that is internet connectivity through GeoSIM, then Geo is one of your internet service provider. Similarly, if you have Airtel, then Airtel is one such thing. Okay, so these are all internet service providers, isn't it, right? So all these are all formed into a hierarchical topology. All these are all formed into a hierarchical topology, and we call the topology in terms of tiered architectures. Okay, so there are three tiers, that is tier 1, tier 2, and tier 3. Basically, the tier 1 architecture has ISPs with a greater scale of cloud provisioning. That means the internet service providers who are present in this tier 1, their major functionality, or else their major point of service, internet service provision, will be in terms of only the cloud providers entity. That means these are the cloud providers community, I can say. Why? Because they have a very huge interconnected global network, and this tier 1 has that's the reason it is in the core. That's the reason it is the core, that is in the center of the architecture what we are discussing, or in the topology what we are discussing. Okay, so these becomes the root for existence of the cloud provider. I will tell you the reason. See, as a cloud consumer, you might be needing low bandwidth or low data speed. That should be sufficient. But if you want to be a cloud provider, then massive amount of resources you will be expecting. With flawless or else with seamless speed, you should be having your bandwidth connectivity, that is nothing but the internet connectivity, and at the same time you're supposed to cater multiple or else thousands of requests, I can say, thousands of requests. Okay, so keeping these things in mind, tier 1 architectures, or else the internet service providers who has massive who are in massive in nature. Okay, they are grouped as tier 1, and most of the tier 1, remember, are the cloud providers only. All the cloud providers will be from the tier 1 only. Okay, now on the other hand, you can see a tier 3. Tier 3. Why sir did not tell about tier 2 in between? Because let us understand the core and the outermost region first, so that it will be easy for us to get to know what's there in the second layer, or else in the middle layer. Okay? So in the third tier, all the local ISPs will be present. all the local ISPs will be present. That means these local ISPs are the one who cater to the consumers. They cater to the consumers. Okay, so the core is filled with the cloud provider, and the outer layer is filled with the cloud consumer. Then who are present in tier 2? Tier 2 also has ISPs, but these are the ones that connect tier 1 with the tier 3. Tier 1 with the tier 3. In turn, they themselves has a limited number of cloud in tier 2 as well, depending upon the kind of service that is being selected by the provider to. Depending upon that, okay, even you can find a minimal number of cloud providers in tier 2, but most of the time these tier 2 people or else tier 2 ISPs are just internet connectivity between tier 1 connections and tier 3 connections. You might be finding crazy, why do you think tier 2 is required, and why do you think tier 3 cannot directly talk to tier 1? I will take you to one example. Let us assume we have Idea network here. I have taken Idea cell mobile network, and through Idea, I get connected to the internet. That's fine. Now, when I move out of the state, I mean, I am local here, isn't it? In AP, I am local here. Now, when I move out of state, I'm not local there. So I should be connected to the internet through some other means. That means Idea will be having their own tie-ups with some other service providers. So my signal or else my cell or else whatever signal I am getting will not be directly through the Idea, local Idea there, but I will be connected through uh, amalgamated what to say in simple words I can tell. In simple words, it's a kind of agreement between multiple service providers, where from outer state I can connect to that sort of consortium based signals only. In the sense, though Idea is present in the Karnataka or Tamil Nadu, if I move into Tamil Nadu, especially if I move into Chennai, let us take in that sense, okay? Though Idea is locally present there, that means as a Chennaiite, I can go and take one local SIM and I can get the Idea connection there. But still, as an outsider, okay, I don't get AP Idea SIM getting connected to the local Idea signals. They will be connected to, you have to believe me, they will be connected through Vodafone. They will be connected through Vodafone then. Of course, now as on today, Vodafone and Idea are one and the same. Similarly, you will be having multiple tie-ups. You will be having multiple types. Why? Because the internet service provider will be having an estimate that how much is the service he need to provide to how many number of customers. He can have that scale. But when people are roaming from here and there, definitely those people will not be able to bear upon how the flow of incoming and how the flow of outgoing requests will be coming in. Do you understand on this? As a local service provider, I can understand very clearly how many number of requests will be there. And see, for example, when I am hosting a tower here in near Srividyaniketan, I can definitely do an assessment study that how many Idea mobiles are there and how many 4G location mobiles are there, and or else how many connectivities are there, or how many Airtel connectivities are there. Likewise, I can have a statistical study, and accordingly, I will erect an tower to provide the signal. But uh, now, let us assume I have erected the signal for 10 persons. Let us assume in that sense. Now, unfortunately, a few people started roaming in, and unfortunately, the signal now has grown to 20 persons. Okay, the same signal has to be shared among 20 people. Now, can you justify that signal? No, you cannot justify that signal. Automatically, though the signal is present, though the connectivity is present, reliability will not be there. Do you remember the availability and reliability characteristic features, isn't it? Okay, the clouds benefit availability and reliability, isn't it, right? So Because of these reasons, okay, tier 3 directly cannot be talking to tier 1. Tier 2 are the one that caters, okay, that caters the needs of tier 3 with the tier 1, with the tier 1. And automatically you can see that tier 1 is most expensive and most massive and most strong internet service provider altogether. But tier 3 is very limited one, very limited one. But depending upon the scenario, you can also see that few clouds are being found in tier 2 as well, as a service provider, so this is how the internet architecture is being topology is studied in terms of the broadband networks. Okay, now moving on to the next technology that enabled cloud into the existence is connectionless packet switching. Connectionless packet switching. See, definitely, as we told that these are all what to say, these are all seamless connectivity should be present, isn't it? So if you had a wide connection, yes, definitely you can have seamless connection. But 90% of the world doesn't go on wire. 90% of the world is reliable on wireless only. Though you have headphones, okay, you can directly connect to the laptop and listen. Still, if you are having wireless headphones handy, then automatically you switch over to the wireless thing. So that's how the people are habituated. So in such a case, definitely when the packets are switching, this is again the basics of computer networks. Okay, so you need to understand how the packet switching is happening, that too in the layered levels. Okay, you remember the 7-layer level, isn't it, right? So to that level, that to that core, how the connectionless packet switching will be happening. Usually end-to-end data flows are divided into packets, as you know, and these packets will be processed through many network junctions, I can say. You can call switches, you can call routers, or you can call hubs, and then automatically at finally it will be reaching to its at destination. All right, and I think you are pretty much sure how this will be reaching to the destination. I think you should have studied all these things in computer networks itself. Okay, or even I'm not sure whether you have studied data communications or not. Okay, even in that subject you can come across these concepts. Okay, so that's about the connectionless packet switching, especially how the data is being switched into packets. Remember, the 5G is entirely packet switching. In 4G, now what the signal what we are using is partially the packet switching. And most appropriately, I can tell that Geo. Do you know why Geo is very fast when compared with other networks? It laid cables basically, man. It laid cables, and the packet switching is awesome and seamless. But definitely there will be some sort of limit, and at times, when there are more users onto it, and definitely even that could cause a failure. That's a different story. Okay, let's not worry about it. But remember that the kind of technology, how the data is being connected in 2G, 3G, and 4G, and the one that is coming in the 5G as well. Okay, that is entirely packet switching. 100% packet switching happens in the 5G technology. So you will not be, I mean, it is something like you will not be having calls with the lower quality, or lower audibility or low pitch. Likewise, those kind of things you will not be finding. If there are if there are packet losses, you could be finding such kind of problems. But in 5G, either you will have connection or not. That's it. One or zero. That's it. It's as simple as that. Okay. So that's about the connectionless packet switching. And the other part of the network is the router connectivity. As we were talking that, tier 2 tier will be communicating with tier 3, and it fulfill its needs by talking again back to tier 1. And there will be many clouds, interconnected clouds as well. Okay, so as the data has to be flying, I should say. Okay, the data has to be flying across many such networks. Definitely router plays a quite important role in routing the data. I'm not sure if you remember in communication theory, or what is that? data communications or communication networks, what you have studied, if usually, the header of the data packet will be having how the what is the route, or is what is the path that has to be taken by this particular packet. And if it fails, if that particular path fails, automatically it has to take some other route and then go and reach the destination. Okay, so all these kind of routing and rerouting will be taken care by the routers. Definitely, all the packets from the what to say, from the layered networks. Okay, the protocols, if you remember, which are present in each and every layer, they create these kind of packets, and they send through the routers. And routers play quite impressive role in appropriately routing and rerouting, I should say. Okay, appropriately routing and rerouting back the data in time. Why? Because see, why we are talking all these things, though these are very basic way of attaining the communication in the computer science, isn't it, right? The only one reason behind these is these sounds to be very simple and very primitive kind of concepts what we are talking. But if these things work flawless, then only the cloud will be existing. If there is 1% flaw also, automatically the cloud fails. Automatically you can claim that the cloud has failed, isn't it, right? So that's the reason these silly things also has to be taken utmost care while you are constructing a cloud environment. And obviously, the connectivity is how the connectivities will be happening. You people very much know how the communication between one IP and another IP will be happening in terms of 7 layers. That is, physical layer, data link layer, transport layer, sorry, internet layer, transport layer, application layer, session layer, and then the application layer, isn't it, right? So you very well know how the header of one layer will be capped up with the next layer, and how the information related to that particular layer is again encapsulated, and finally it becomes one such packet. That packet will be physically sent to through certain to certain router, from where that router will be sending through the wireless. Okay, through the wireless network, that means through the internet, to the some other routers, from where it will be reached to again routers of other network or other sub network for that matters. Okay, and finally it will be going and reaching to the destination, where on the destination IP again relevant layer will be taking out their headers, and they take out their headers and they free the data for consumption. Okay, it's not new one, and I don't want much time to spend on this, as you are already aware of these layered technology. So this is what is the technical issues that can be coming usually as the considerations. Okay, so here in the diagram you can see that, see, this is one particular cloud network, and here you can see the users. All these people are connected through routers and corporate internet connection, isn't it, right? So on the other hand, you could also have a direct uh, virtual servers also being connected. See, if you see on the right hand side image, okay, the same physical network has been replicated on the cloud, okay, making this as off premise and this as on premise, and so that this will be readily available for all kind of usages. This is a quite very generic one and very primitive one, I can say. Okay, so how the connectivity problems can be arised on on-premise network, and that is off-premise network. That is nothing but the cloud-based network. Okay, so usually when it comes to the connectivity issues. Okay, so for the connectivity, internal end user devices usually access their services through this corporate network, or else through organizational network, on simple words I can say. On the other hand, the internal users also has these IT services, through the means of even from the roaming extensions, even from the roaming extensions, like I had told you, isn't it? Say for example, we have this NIVA network, and I can access to this NIVA only when I am connected in Sri Vidyanaketan network. That's fine. But if I'm moving out of town, and if I want to join or else if I want to access this application again from the remote location, I need to first get into the Vidyanaketan's network, and then I should be accessing to NIVA, if at all, if it is in what to say, private kind of cloud. Okay. And obviously the external users, okay, remember the external users, that means I don't belong to the Vidyaniketan network, okay, but still uh, external users still can have the access, but provided they will be having certain type of limitations. Same is the case, okay. If the resources are present in the off-premise, that is nothing but the cloud-based entities, okay, definitely they'll be requiring not the organization network, but they'll be requiring what? Trusted network. That is nothing but the internet connectivity, okay. And definitely even internal, in this case also, internet users can have their services enabled even when they are roaming, but provided they are supposed to have a proper internet connection. And obviously external users will also have the similar kind of thing. There is no much change. Why? Because external users doesn't mind, or else doesn't even know, or else doesn't even get a clue at least whether the resource that is he is accessing is an part of on-premise or off-premise. He don't bother also about that. Okay. So that's about the kind of connectivity issue. Next is usually you will be coming across the bandwidth issues and the latency issues. The bandwidth is not sufficient enough to check, or else many times even when we people are handling the Zoom classes, the bandwidth will not be sufficient enough, and hence most of the time we try to switch the video off to maintain the bandwidth. And latency is something like, you will get the mismatch between the audio and visual. Usually, audio will be slow, visual would have been fast. So these kind of problems will be definitely creating chaos in service consumption. Something like, if you are accessing an ATM, and you are using, let us assume a differently able person is using that ATM, and he would like to get heard about the options that have been present. Say like, when he is supposed to enter the pin, and when he is supposed to enter his information, when he is supposed to enter the money. Okay. So if there is no mismatch between the voice over and the screen that is being shown, then definitely don't you think there is a problem, isn't it? Right. You claim that the bank has not provided the service appropriately, and the banker will definitely go on through the ATM networks. That's how they function, isn't it? Right. So that's about the network bandwidth and latency issues. On the other hand, you have certain consideration, especially for the business consideration, when you choose appropriate cloud providers and carriers. Why? Because quality of service is the one that finally your business will be expecting all. If you don't expect proper quality of service, then automatically you would like to switch over, isn't it? Right. And especially when it comes to the cloud, you cannot just plug and play with the things, isn't it? Right. So if you opt to one particular cloud, then it will be really tough time for you to change. Why? Because it is the risk and challenge of the cloud, isn't it? The portability between the clouds is not possible, isn't it? Right. So the first moment itself, when you try to choose appropriate cloud provider and the carriers itself, you should be very cautious, and you should be well aware of the kind of quality. You got it. Okay. Now, for example, I cannot say that, let me try with IBM Bluemix. This is so new, or else this is, my brother is working in IBM company. I might get some fetching out of it. Now, I will create my resources on IBM Bluemix, but later the brother shifts to Microsoft Azure, or, Zoho, or some other cloud provider, then similarly I cannot immediately switch over my resources. I need to pull down all the resources in IBM Bluemix, then I need to restart from the scratch. That's the portability kind of issue, isn't it? Right? Okay. So we have to be very cautious enough in choosing the cloud providers. Okay. Now here I stop the class for today, and in the next class we will see the data center technology, which is being which plays a prominent role in cloud for being enabled. Okay, let me stop the sharing, and I am open to take the doubts. Are there any doubts? If so, then I end the class. Thank you.